Hello, everybody. Your Alex assignment for today was on Chapter 10, Lessons 1, 2, and 3, and there are 10 questions. And I'm going to go through some of the trickier problems to kind of help you with today's assignment. Number 1, we have to fill in a table using the function rule. F of x equals the square root of x minus 5. It says to simplify your answers as much as possible, click not a real number if applicable. Okay, so for these we are trying to see, okay, is there a real answer? And then if there is, what is it? If there's not, then we need to put not a real number. When we get not a real number, that is when we have a negative inside of the radical sign. So for example, on the first one we are plugging in 4 for x, so if I take the square root of 4 minus 5, well, 4 minus 5 is negative 1, and the square root of negative 1 is not a real number. So number 4 would be not real. When I plug in 5, the square root of 5 minus 5, that is 0, so the square root of 0 is 0. And if I keep going and follow this, I will get my answers, and I can plug in the numbers that I have. Now, when I do the square root of 69 minus 5, I get the square root of 64, and the square root of 64 is 8. And then last one is the square root of 105 minus 5, which is the square root of 100, which is 10, right? So that's the idea behind number 1. Number 2, we have this function, and we need to find the domain of the function. F of x equals the square root of x plus 3. Write your answer as a inequality, or you may instead click on the empty set or all reals as the answer. So remember, the domain is the x, so we're trying to figure out what numbers will work for x. And in this case, not every x is going to work, so it's not going to be all real numbers. So we have to kind of look at, okay, what numbers are going to work here? And the way we want to look at this is we want to see, okay, what is going to make the inside of this radical sign 0, right? So if I were to set x plus 3 equal to 0, we would find that x would have to be negative 3. What this does, this tells me what makes the inside 0, right? Because negative 3 plus 3 is 0. So if I go one more to the left, or if I go one more negative, right, say I chose negative 4, well, negative 4 plus 3 is negative 1, and now all of a sudden we don't have a real number. So negative 3 is my target point here. And we're trying to figure out, okay, since we can't go more negative, then it has to be everything greater than or equal to negative 3. So x has to be greater than or equal to negative 3. So that's the answer for number 2. That's how you would go about finding it. For the next problem, you have to graph the function f of x equals the square root of x plus 3. It says plot 4 points on the graph, the leftmost point and 3 additional points. Then click on the graph a function button. So you can plot those points in here to graph the function. What I recommend is using the Desmos graphing calculator for this one. So f of x equals the square root of x plus 3. So we can plug that in here. So you can use y for f of x if you wanted, equals the square root of x plus 3. Right? And the leftmost point is going to be at wherever your x-intercept here is. In this case, it's going to be negative 3 is my leftmost point, and I would need additional points, so negative 2, 1 would be in a point. And remember, you could also use the setting button and then make a table, and it makes it very handy to figure out, right? So if I type in negative 3, we know that's a point. So negative 3, 0, negative 2, 1, 1, 2, and then and you could keep going. It looks like the next point is that Desmos graphing calculator to help you. The next question is number 5, where we have to simplify the square root of 18x to the 21st power. So remember, we can kind of split this apart and think about this as two different roots, so the square root of 18 and the square root of x to the 21st for the moment. And we need to break these down into perfect squares. 9 can be broken down into 9 and 2, or sorry, 18 can be broken down into 9 and 2. And we know that 9 is a perfect square, so the square root of 9 is 3, and we're left with root 2. X to the 21st we know can be broken down into x to the 10th, x to the 10th, because 10 plus 10 is 20, with one additional x left over. So we can take out an x to the 10th, so we are left with 3x to the 10th in this case, and then 2x's on the inside. Since these two numbers and variable, this number and variable does not have a perfect, is not perfect, we have to leave it inside the radical sign. And the last question that I'm going to go over in this video is number 8, where we have to rationalize the denominator. We have to use a complex, you have to use a conjugate to eliminate the radical sign in the denominator. Remember, the conjugate is multiplying by the same exact thing in the denominator, except we're changing the sign. So it's going to be plus 1 here. So this is 3 root 2 plus 1. So when we multiply, this is going to be 7 times 3 root 2 plus 1. And then this is going to be 3 root 2 minus 1 times 3 root 2 plus 1. Right? And if we multiply that out, we have 7 times 3, which is 21 root 2. 7 times 1 is 7. And now we have to use difference of squares for the denominator. So 3 times 3 is 9, and then 2 times 2 is 4, so 9 root 4, and then minus 1. We know that the square root of 4 here is 2, so 9 times 2, which is 18, minus 1, which is 17. So my denominator is going to be 17. And my top, I can't simplify, unfortunately, because everything is, we have no common factors, so we have to leave it as it is. So 21 root 2 plus 7. Okay, so I kind of hope this video is helpful. One of the trickier questions I definitely want to make sure I went over was that graphing question. Remember, please use the Desmos graphing calculator if you have the option, just because it's going to make it so much easier and it's going to be way more efficient. So I hope this video is helpful, and yeah, you guys are doing a great job staying up to date on your assignments, and I appreciate that, and I hope that you have a great day, and thanks for watching.